What it do, E-World? Crisscrossing wires. Back with another video. As always, doing it the cheating way, doing the live stream because it's easier and I ain't gotta upload shit. Y'all know how I do. Do anything the easiest way possible. Anyway, guys, today's video is about, first of all, is about bottlenecks. Alright, and mainly for you Surron guys, should you do a circuit breaker delete? Now, depending on how anal you are about getting the maximum current flow, I would say absolutely a yes for me, because I want all my amps. There's no need in building or purchasing a high output battery pack if the means in which you transfer that power to your controller isn't all in line with the battery. Okay? You got a battery that can output 500 amps. There's no way in the world that you want it to be, you want that current flowing through something that can limit it to 100 amps. Now, a circuit breaker that's rated at 100 amps, that's about all the current that can actually flow through that circuit breaker. Now, obviously it probably can stand a little more than that, but not much more, and all that's going to do is cause a lot of voltage sag, because anything that interrupts your current flow is going to cause voltage sag. Alright, now I'm sure there's going to be a lot of scary guys out there, especially with battery fires, blase, and guys that don't understand what a circuit breaker actually does, and the reason why Surron put circuit breakers in their bikes are going to be scared or say no, they won't, let me tell you, man, a circuit breaker is supposed to pop open if there's a surge in current which is more than what that breaker is rated at. Just like a fuse, it's a protection thing. Okay, now and I'm going to also say this: a lot of those circuit breakers that are in those Surrons, they must be terrible cheap circuit breakers, because I know a lot of you guys are running more than 100 amps and those circuit breakers aren't popping, so they're not even doing what they're supposed to do. But they are doing what Surron designed for them to do, and that is make it so when you remove and put your battery back in your bike, you don't get that loud pop when you connect your power leads. Alright, now initially that was their main reason for them putting circuit breakers in there, so you could shut the circuit breaker off, connect your battery power, then switch the circuit breaker back on, and you didn't have to deal with that pop that you get from that initial rush of current going back into your controller. That is why you get that pop sound. Alright, controllers have capacitors inside of them which store energy. Okay, you can check if you were to disconnect power from your controller and then immediately try to go and turn your display on or your bike on, it would flash on for a second until that energy that's stored in that controller depletes out, and you'll see it fade out. Okay, so when you first connect power, it rushes into those capacitors and you get that pop sound. All right. Since then, they have also came out with anti-spark connectors. Okay, and those anti-spark connectors have a resistor inside of them that limits the flow of current, so you don't get that initial surge and pop. Now, did you hear what I said? Those anti-spark connectors limit the flow of current so you don't get that pop. Now, for those of you like myself that want maximum current flow, we don't want anything limiting flow of current. All right. So, like I said in the beginning, this isn't for everybody, but if you're a power hungry madman like myself, mostly for you race guys out there that want the best performance possible, like I said, if you're not racing, if you're not trying to get your 0 to 60 times down as low as possible, or quarter-mile times, or high speed, top speed runs the best possible, then you don't need to worry about any of this. However, if you are that type of guy that's a power-hungry madman like myself, you want the best performance possible. I build my packs so they can produce a high amount of amperage, because a good pack doesn't just have high output cells in it. A good pack is also constructed in a way, the way that it's set up as far as its series parallel connections. Not only that, the materials used in your battery have to be hefty enough, of good quality enough to pass that tremendous amount of current that you're trying to get. If all that's not in, all together, then you're limiting that. Okay, so bam, you got your high output battery. It can do 500 DC line amps, and you're gonna hook it to your controller. But on the Surron, you're hooking it up with the power leads that are there in that bike that run through that little 100 amp circuit breaker. You just negated the money you spent on that high output battery and that high output controller by having it run through a 100 amp circuit breaker. Okay, now like I told you, some of your circuit breakers aren't popping, so it is allowing current to flow through there, but it's not allowing 500 amps to go through there. So that is why when you have your controller set at 300 or 400 DC line amps, 600, 700, 800 phase amps, and you throttle down and your voltage is sagging way back, sag does not always come from the cells that's in the pack not being able to output tremendous amounts of power. Sag also comes from bottlenecks. Anytime that flow of current is being impeded, you're going to have voltage sag. Now, you ain't got to take it from me, but trust me, I'm all about efficiency, all about getting the maximum performance out of everything. Me, myself, not speaking for anyone else, because and said in the beginning, I'm trying to build a high performance bike. I have built a high performance bike. And because it was my bike, nobody's working on that bike but me. I have done everything in a way that I'm going to get the maximum out of everything. I don't have any QS8s on my bike. I don't have any quick disconnect. My power leads from my battery pack are 0 gauge. They go straight to my controller. No line loss at all. I guarantee you can put your multimeter in my bike and you're not going to get any resistance measurable from my controller to my battery. All right. Now, like I said, that is me. That is how I'm running. That's because I'm not taking my pack in and out of my bike. My pack stays in my bike. And like I said, my pack was built to produce a whole bunch of amps. And I'm not putting nothing in that's going to stop those amps. Alright. Now the choice is yours. Now let me show you a few things, because I had some things ready to go. Now these are the circuit breakers that are in those Surrons. As you can see, these are replacement ones. They're not really expensive. 25 bucks. You look them up, most of them are 100 amps. Now I was wondering, there should be, you can buy damn near anything for a Surron, but I didn't really see any replacement circuit breakers that were, like a 300 amp circuit breaker or a 400 amp circuit breaker. If you're one of those people that like, I gotta have a circuit breaker in there, I feel better with a circuit breaker, well, make sure you got a circuit breaker that can handle high output. And unfortunately, I don't see any. Now, if you're using a circuit breaker because you want protection in case of a short circuit, there's other things you can do, like use those car stereo blade fuses. You can get some of those that are 200 amp. They have them even larger, or you can use 2 of them and double up that power. 200 amp blade fuses that give you 400 amps worth of protection. When you get a short, there's going to be maximum current flow. That's what blows the blade fuses and supposed to pop those circuit breakers. Probably a dead short hopefully will trip one of those circuit breakers, but obviously 200 amps doesn't. I know some guys running at least 200 DC amps, and they're running it right through those things, and all they do is get hot, and get hot and impede the amount of current flow. Now I can even show you what those circuit breakers look like on the inside. Now this isn't exactly the same circuit breaker, however, it's oh man, I ain't even got it on screen. My bad. So let me switch. Sorry guys, bear with me. Aha. Okay, I'm doing this in real time. I'm gonna fix this. Let me put me over here. Oh man, this is terrible. So let me go back to where I was showing you guys. I thought I was showing you a picture of the circuit breakers. These are the circuit breakers right here that I just went through a little while before. But anyway, this is the important part now. Finally got that on the screen, so let me show that. This is inside of your circuit breaker. As you can see, there are just contacts in there. Right here is where one side of the power wire comes in, the other power wire goes out on that side. In between there are these contacts, and that is it. See those little metal contacts in there? Not only that, these little braided wires right here, current also goes through those little braided contacts as well. So you got supposedly 400 or 500 amps or 300 amps, whatever your controller is. Those amps are supposedly flowing nicely through this circuit breaker. Now, trust me, 500 amps ain't flowing through there. Only 100 or 150, 200 amps at the max is the only amount of current flow that can flow through there successfully and, get your full output and cause you not to have all that voltage sag. Alright? So, think about that. Now, if this were a 500 amp circuit breaker, trust me, all this would be a lot larger, a lot thicker, and you wouldn't have that issue. But it's only a 100 amp circuit breaker, so there's a problem. Let's look at these QS8 connectors. All right, now it's crazy how some of the advertisements for QS8 connectors say 300 amps. If you look at the fine print and how much constant current flow, 110 amps. 110 amps is the amount of current that can flow through these QS8 connectors. And yes, I know they have V2s. They have the, you know, supposedly the upgraded version, which should have a little bit more material, metal in there, brass, whatever that is, contact in there should be thicker and beefier to handle more current flow. But QS8s, 110 amps. Let's look at QS8s with what most the normal leads that are put on QS8s is 8 gauge, sometimes 6 gauge. So here's a QS8 with the leads on it. How much current can flow through there? 110 amps. 110 amps is all that can flow through this connector and that cable. Now, I notice good battery companies like Powerful Lithium, shout out to those guys, even though they don't know me, they build decent batteries. I wouldn't say they build super high output batteries, but they build really good batteries. They can build super high output batteries, I'm sure, if someone requested one, but their average batteries that they're selling on a daily basis, nobody, you know, not too many people are running more than 300 DC line amps. So their batteries are plenty sufficient for that. And if you notice, they use 2 sets of leads. Okay, if you double the leads and double the connectors, you're doubling the amount of current that can flow from your pack. So a lot of their packs have dual sets of leads, which are probably more than these 8 gauge. I think they use 6 gauge. So 6 gauge with a V2 connector on there probably can pass 150 amps continuous. They use 2 of those, so there's 300 amps. Now remember, they're using 2 sets of leads off of their pack. You need to have 2 sets of leads on your controller. You're defeating the purpose of them putting double sets of leads if you only have 1 set of leads going to your controller. So you need to double up on your leads going to your controller as well. And like I said, my opinion, if you have a Surron, get rid of that circuit breaker. Alright, it's a bottleneck. Once again, I'll repeat, bottlenecks are going to give you voltage sag. Now, I'm also going to say, once again, I'm not saying anything about Powerful Lithium batteries. I think they're building some of the best packs out there that you can buy. You know, I look at, I pulled up Chai batteries and looked at their packs. I looked at how they were building them, what they're constructed with the nickel. Matter of fact, let me go ahead and pull up Chai batteries. Chai battery systems. Let's see. And they build quality packs, no doubt about it. But I was checking out, you know, were they putting dual sets of leads on their packs? And let's look. Let's see. Is this a Surron pack right here? Okay, let's click on that. Let's look at the specs for this. Okay, 51 amp hour, using Molicel 21700s, power rating 30 kilowatt, and far as the connector, a QS8 Super or QS10 options. I think I only saw one set of leads coming out of this pack. See that? One set of leads coming out of that pack. Now, do they have packs with dual sets of leads? I don't know. But they sure don't. I don't see them on their page right here. So maybe they do. I'm just trying to tell you guys. See, QS10 and 6 gauge. Okay, so it does say select super option for stock harness capability. Also now available with QS10 and 6 gauge. Okay, so 6 gauge and the QS10 is definitely going to pass more current. Definitely better than 8 gauge with a QS8. But powerful lithium. I think they're running dual 6 gauges with dual connectors. So yeah, a little hard to beat that. Anyway, next type of bottleneck, obviously, is the BMS. Now, obviously, most licensed battery distributors are going to sell batteries with a BMS, and BMS operating on the charge side and on the discharge side. Now, do they make high power BMSs? Absolutely they do. 500-600 amp BMSs, they sell them. They're really expensive, but at the end of the day, it's still going to be a bottleneck. As you can see, these are some wiring diagrams of how most BMSs are connected to your battery pack, and your ground is the side that runs through the BMS, so current actually flows through the actual BMS inside through the circuit board and then back out to the leads that go to your controller. Alright, so the power coming out, once again, the power coming out of your pack, let's see over here, is going to be going through the BMS before it reaches your controller. So depending on that circuit board that's in the BMS, I don't know what they're using as far as the traces that is handling all that power come through there. I'm pretty sure it's copper or whatever, but it's a circuit board, so I'm sure the ones that are high power, those 500 and 600 amp controllers, they gotta be beefed up on the inside. They gotta be beefy. Me myself, because I'm balls to the walls, I don't run through the discharge side on my BMS, because once again, no bottlenecks for me, but I'm an insane power grabbing monster. So I don't recommend everyone do that, but like I said, for those of us that are trying to get the max at the end of the day, I'm not gonna feel good about putting 400 or 500 amps through a BMS or connector. Alright, so anyway, that's pretty much it, man. I really didn't want to okay, let's see, let me show you guys here. I did show these stats before, but let's see, this is, as you can see, when I show you these and you see the start voltage and the end voltage, that is the amount of voltage sag that's happening. These are snapshots of one moment in time when my controller was making 32 kilowatt. It was roughly pulling 468 amps, and outputting 834 phase amps. As far as torque, it was making 642 newton meters of torque. That is an awful lot of torque, guys. But that's because, as you can see, I was getting a nice bit of current flow there, while my voltage was staying up with not that much sag. You know, I was losing a volt, which is great at that amount of power. Now I'm going to show you before. This was the battery system. Before that, this was when I had a NB power pack and some lipos in parallel. And although it was still doing pretty good, I was able to make 26 kilowatt, 380 DC amps. I was getting 520 phase amps. But as you can see, I was only making 356 newton meters of torque. And my voltage was sagging. Obviously this wasn't a full charge, so it was sagging even more. It was at 80 volts, and it was dropping all the way back to 68 volts. So that's 12 volts of sag. But that is before I had my new custom pack. That is with connectors and all that other stuff in line that gives you sag. It was bypassed, so you know, it's just that that pack and those lipos just couldn't you know, keep that voltage up there. So as you can see, you lose a lot of power, especially when your voltage drops like that. Obviously your output power is going to drop. Volts times amps equals watts. So if your volts is dropping back to 68, you're losing power. Alright, let's see, that's me. This was I made a video, you know, showing my battery process. Most of you have seen that, how I make batteries with my bus bars and all that. And then I even had a little video with some performance right here. As you can see, that's about 380 some amps. Went to 80, and then when it goes negative, that's above 80, so that's about 85 when I got off of it right there. You know, it's 80, then negative 79, 81, negative 78, 82, so about 85 I got off of it. Obviously it's very hard for me to do a top speed run on my road. Top speed, you know, you have to stay on the throttle, and eventually you're going to get towards the end of your range. Those last few miles per hour is going to take a couple seconds, you know, before you know how it is when you get to your end of your range. It might be 67, 68, 69. It's moving real slow at that point. But hey man, it is what it is. Anyway, let me see, what else anything else I wanted to add to this, man? No, that was it. Yeah fellas, bottlenecks are going to give you some sag. So that's just my thoughts on it. You know, if you're going to keep circuit breaker, as I said, try to get a large circuit breaker, or you may have to use a couple of those as well. You want to keep, so you might need 3 of those to get 300 amps. You know what I'm saying? But I wouldn't go through all that, man. Get rid of that circuit breaker. Oh, let me tell you something else you can do. We were talking about anti-spark. Oh, that's something I wanted to talk about. So let me go back to that. These QS8s. If you look very closely, maybe it didn't show up on that one. Let's see here. Trying to get a close-up of one of these QS8s. shit. That's why I try to have all this stuff ready to go. Bear with me, deal with me, fellas. Damn it. Just a bitch. Sorry guys. Anyway, what I wanted to say, these anti-spark ones, they have a 5 ohm resistor inside of them. Okay, that 5 ohm resistor, what that does is limit the amount of current flow. So when you hook your battery up, it's not a great big surge of current going through there, and that is why they don't spark. Alright, now at the same time, if you're trying to get maximum amps, you don't want no damn resistor in your connector. Alright, so what you can do is also, you know, have a second set of leads on there. You're already running 2 sets of leads because you're trying to get the maximum amps. But you can even put another connector on there with an anti-spark if you don't want to use that for your power leads. And when you initially connecting your controller, plug up that anti-spark resistor first. Connector first. That's going to charge up your controller. You know, if you immediately unplug it, then you can plug up your other connectors that are not anti-spark but giving you your maximum current, and you won't get that pop. You know, use the anti-spark one to charge your controller voltage up, because the controller store voltage, and once they get their 84 volts in them or whatever, it's not going to spark when you immediately make the connection. So if you charge up with the anti-spark, you know, and then immediately disconnect and immediately plug up the other lines, you won't get a spark, and you won't be running through connectors that have a resistance. Alright, I don't want connectors with resistance. But again, that's for the power hungry power monsters like myself. Alright, y'all, take it easy, take care. Sorry about the video, you know, and me not being prepared and losing my trains of thought, but you know how it go here. We raw, R-A-W, just like the power I run on my bike, raw, R-A-W. And if you want to keep it raw, you ain't running no circuit breaker. Deuces. We out.